Hello, welcome to Unit 3, Lesson 3 with Professor Blackman. Today we're going to be solving systems of equations using the elimination method. In our previous video, we used the substitution method, and we're going to be doing very similar things here. We're going to solve a system, and then we're going to solve some applied problems. We talked about special cases before. With the elimination method, there's some notes right here that if you want to pause this video and copy them down, it could be very helpful as you work through these type of problems. So I want to talk a little bit about how this elimination method works. So there's a rule that says if A equals B and C equals D, then A plus C equals B plus D. Now this is algebraically, I can put it in basic terms. 1 plus 1 equals 2, and 3 equals 2 plus 1. Now these are two equations that are the same. So 1 plus 1 represents A, and 3 represents C. So then we can say that 1 plus 1 plus 3 equals 2 plus 2 plus 1. And the left is 5, and the right is 5. So if the two lefts are added together and the two rights are added together, we end up with equations that are equal. So let's go ahead and look at some examples. So here in problem 1, we have two equations. And what we're trying to do is eliminate one of the terms. So if you look at the y's, you have positive 3y and negative 3y. So when we add those together, they will cancel out. So 3y and negative 3y cancel out. 3x minus x gives you 2x. And 15 and negative 11, when you add them together, you get 4. 2x equals 4, so then x equals 2. And again, this x equals 2 is an ordered pair. So this is the 2 right here. We need to figure out the other part. Now, the second part is very similar to substitution. You're going to take this x equals 2 and plug it into either one of those equations. I'll plug it into the second one. So negative 2, because 2 is now x, minus 3y equals negative 11. Negative 3y equals negative 9. Divide by negative 3, and y equals 3. And it is always recommended that you do check your work. So since we use the second equation to generate the y, we should just check using the first equation. So 3 times 2 plus 3 times 3 needs to equal 15. 6 plus 9 does in fact equal 15. So we can be 100% confident that that answer is correct. All right, let's look at our next example. So again, the y's here are opposites of each other. So they will cancel out. And when we get negative 2x, when we add the x's together, and we get negative 1. Divide by negative 2, and x equals a positive 1/2. So that is an ordered pair where we know the x is 1/2. Now we've got to figure out y. So I'm going to plug into the first equation. 1/2 is replacing the x, minus 3y equals 0. Half of 2 is 1. So 1 minus 3y equals 0. Negative 3y equals negative 1. Divide by negative 3. And y equals a positive 1/3. And then we would want to check that. And since we use the first equation to plug in to find the y value, we only need to check in the second equation. Negative 4, x is now 1/2, plus 3, y is now 1/3, and this all needs to equal negative 1. Half of negative 4 is negative 2, 1/3 of 3 is 1, and we get negative 2 plus 1 does in fact equal negative 1. All right, let's go ahead and look at our next example. So when you look at these equations here, we have 5x and 3x. Those aren't opposites of each other. And 3y and negative y. Those aren't opposites of each other. But what we can do is we can multiply this equation by a 3. Multiply the entire equation by 3. And we know from solving that as long as you multiply the left side and right side by the same thing, the equation stays balanced. And we get 9x minus 3y equals negative 3. And now you can see this negative 3y is the opposite of the 3y that is in the first equation. Now when we add these together, the y's cancel out, and we get 14x equals negative 14. Divide both sides by 14, you get x equals negative 1. Now we can take that negative 1 and plug into either one of the equations. I'm going to go ahead and plug into the second one. So put that negative 1 in for x, minus y equals negative 1. So you have negative 3 minus y equals negative 1. Add 3 to both sides, and you get a positive 2. Divide both sides by negative 1, and you get y equals negative 2. So then we get the solution as negative 1, negative 2. And then I will go ahead and check that. It is always good and recommended that you do check. So since we use the second equation, we will plug in using the first equation. 5 times negative 1 plus 3 times negative 2 needs to equal negative 11. Negative 5 minus 6 does in fact equal negative 11. So this is our correct answer. All right, let's look at the next one. So we need the r's to be opposites. So the easiest way would be multiply the first equation by 2 and the second equation by a negative 5, and they would become opposites. Or we can look at the s's, and since negative 3 and 6, if you double 3, you get 6. So what we're going to do is we're going to multiply this by a negative 2. This, we're going to leave, the second equation, we're just going to leave exactly how it is. So we get negative 10r plus 6s equals negative 38. And 2r minus 6s equals negative 2. Negative 10r and 2r give us negative 8r. The s's cancel. Negative 38 and negative 2 give us negative 40. Divide both sides by negative 8, and you get r equals 5. All right, now that we have r, we can go and find s. So I'll plug into the first equation. So 5 times 5 minus 3s needs to equal 19. So that's 25 minus 3s equals 19. Subtract 25 for both sides, and you get negative 3s equals negative 6. Divide both sides by negative 3, and s equals 2. So our ordered pair, r comes first alphabetically and first in the equation. It'd be 5, 2. And let's go ahead and check. So again, we plugged into the first equation, so here we'll check using the second equation. 2 times 5 minus 6 times 2 needs to equal negative 2. This is 10 minus 12 does in fact equal the negative 2, so 100% right. And we are ready to move on to our next example. All right, so with this one, we need to get opposites. So if I want to turn a 2x into a negative 4x, I'm going to multiply the top by a negative 2. I'll leave the bottom exactly how it is. 4x plus 6y equals 2. And the top would be negative 4x minus 6y equals negative 2. Well, if you can see, that cancels, and that cancels. So we get 0 equals 0. All right, let's look at this next one over here. To turn a 3x and 3x into opposites, we just need to multiply one of them by negative 1. And it doesn't matter if we use the top or the bottom. I'll go ahead and do it to the bottom and leave the top equation exactly the same. And that gives us negative 3x minus 2y equals negative 26. So when I add those together, that cancels and that cancels. So that 0 equals negative 2. So these are those special the special cases I talked about on the first slide. 0 equals 0 is always true. So this is infinitely many solutions. And 0 equals negative 2 is never true. So this would be an example of no solution. So for graphing, no solution, these would be parallel lines. And these would be the exact same line. As you see, if you double this first equation, you will see it equals the second equation. All right, so those are your special cases. Let's look at our application problems now. All right, so we need to start by creating our two equations to form our system. So the sum of two numbers is 3. So x plus y is 3. Sum means addition. And 3 times the larger number, so 3 times the larger number, I'll define the larger number as x, plus 2 times the smaller number, so 3 times, 2 times the smaller number, which I'll define as y, so 2y, is 24. Is means equals, and 24. So we have 3x plus 2y equals 24. And now we can solve them. We need to get opposites. So we can multiply by a negative 3 to cancel out the x's, or a negative 2 to cancel out the y's. I'll choose the negative 2, so that way we're using smaller numbers. So this is negative 2x minus 2y equals negative 6. And the bottom equation I'm going to leave exactly the same. Now when I add them together, y's are canceling out. 3x and negative 2x give me x. 24 minus 6 gives me 18. So the larger number is 18. Now let's figure out what the smaller number is. Well, we can plug that into the first one. 18 plus y equals 3. So y equals, subtract 18 from both sides, you get negative 15. So 18 is the larger number, negative 15 is the smaller number. And since we use the first equation to generate our y, let's check using the second equation. 3 times 18 plus 2 times negative 15 needs to equal 24. 3 times 18 gives us 54. 2 times negative 15 will give us a minus 30. And that does, in fact, equal 24. So larger number, smaller number. All right, let's look at our next example. All right, each course offered at a college is worth 3 or 4 credits. The members of the college choir took a total of 33 courses worth 107 credits. How many of each type of course did the choir take? So 3 credits or 4 credits for 107 credits. So 3x plus 4y equals 107. So that's all the credits. And then they took a total of 33 courses. So that would be x plus y equals 33. So if they took 30 of the 3 credits, that's 4, then there's be 3 of the 4 credits, but we need to solve this to figure that out. Okay, so I need to multiply by something to turn the x's opposites or the y's opposites. So to make x opposites, I need to multiply by a negative 3. To get the y's opposites, I need to multiply by -4. I'll choose the smaller of the two numbers and multiply the bottom equation by a -3. So then we have 3x plus 4y equals 107, and -3x minus 3y equals a -99. The x's will cancel, and we get y equals 107 minus 99 is 8. So y is the 4 credit classes. So this is the 4 credit classes. Okay. And then we can plug in to one of the other equations. I will choose the second one, where it's x plus 8 equals 33. Subtract 8 from both sides, and you get x equals 25. So 25 plus 8 does give you that 33, and now we just need to check in that first equation to see if it equals the 107 that we needed to equal. So let's check. 3 times 25 plus 4 times 8 needs to equal 107. That's 75 plus 32, and that does equal 107. So this 25 is the 3 credit classes. All right, that's all I have for you today. Happy studying.